Hello and welcome everyone. So in this video I'll be discussing about problems or programming problems regarding tree, and oftentimes it might happen that we are stuck at some corner cases we can't figure out. So what could be the most convenient way that we could check for that particular tree problem? Well, we know what a I hope you guys know what a tree is. A tree is like a connected graph with n vertices and n-1 edges. Okay, now the first case that we're going to discuss is, or like the first corner case that we could try out and check whether our problem solves the case if the vertices number is 1. For this case, here our vertices number is 1, and in this case the tree would look something like that. It will have only 1 vertices and no edges, since n vertices and n-1 edges with a connected graph is called a tree. So this could be one case. So we could try out for this tree whether it solves the issue for our corner cases regarding any particular tree problem. Okay, let's say we have figured out that it actually solves that part. Then we could also see or manage a test case with a star tree. This tree is known as a star tree, where we have one central node and the other nodes are surrounding that central node. It does sound, or like it looks like a star tree, that's why we're calling it. It looks like star, that's why we're calling it a star tree, as you can see. So this could be one the other tree that we could try out for possible corner cases that we might get wrong answer. So yeah, so this is like the second possible corner case testing tree that we could try out. And yeah, the third one is pretty convenient, which is here. I hope you guys know a term known as the diameter. Diameter is like the highest value of the path between highest distance of the path between two nodes in a tree. And sometimes when we draw a tree, the tree itself could become the diameter, meaning that there won't be any other branches apart from the diameter. So as you can see here, the diameter itself is a tree. Of course, there could be other branches, but I mean, according to the definition of diameter, which is the highest distance between two nodes, as you can see, this could be the start. You could call this as the starting node, and this you could call this as the ending node, and their distance is the diameter of a tree. And sometimes the tree itself could be a diameter. The tree itself could look like a diameter with not having any branches at all. And you could try out that for a possible test cases, like possible corner cases, such that it solves the issues regarding your problem or not. Okay. Then after that, of course, the general tree, right? This is the general tree. Okay. Normally a tree does look like that, but normally when we try out different test cases, we might draw a simple binary tree or a tree having 2 or 3 childs and make it. But any of the trees we might wanna you might wanna convert that tree and make a shape like that, where you will only focus on the diameter at first, and then you will focus on the branches. Okay, the diameters each and every node could have different branches. So any tree, you could visualize it like that, and that will definitely helps regarding solving programming problems regarding tree. I hope you understand what I mean by you could visualize the same tree as some form of binary tree or simple tree, as we normally do when we make this node as root and it has some child. What if we could visualize it like that in terms of the diameter, in terms of the diameter's first node? Okay, you might visualize that. Definitely does help regarding solving some problems, or maintaining or like try to understand uh, what's I mean different features, or any sort of solutions that might come up. Yeah, so like, yeah, in order to get particular observation, this sort of trees, if you visualize it, the tree like that, that might help you. So yeah, these are the several forms that we could use in order to try to find out and figure out different observations, and trying and solving corner cases regarding the tree problems. And one thing to notice is that it's not always obvious. It's not like always convenient to go from the root of a tree. Sometimes you might want to try to make traversing from the leaf, and that might also help solving different problems. So yeah, yeah, I hope you understand what I'm trying to say here. To solve different to solve tree problems in different ways, trying to figure out the corner cases, and going from root might not be a convenient solution for every problem. You might want to go from the leaf nodes, or any tree problems. You might it might be much more convenient if you go from the leaf rather than going from, or traversing, or like thinking the problem in terms of the root. So yeah, these are like the basic possible cases that we could do when trying to think about a problem regarding trees. And yeah, I guess that might help you in solving the problems. Yeah, so yeah, till next time, goodbye.